So in question number 10a, it asks for the average velocity of the following graph from t equals 0 to t equals 20. So we are looking at using the fundamental theorem of calculus, and we're going to calculate average velocity. So in this case, since the y value is velocity, what we're trying to find is the average height of this graph. So the average value of a graph can be found by taking the area and dividing it by the interval width. So here the interval width is 20 minus 0. That's how far we've gone from t equals 0 to t equals 20. And then this integral represents the area portion of this. So we have to calculate both parts. So looking at this, I'm going to have my average velocity is going to be 1 over 20. That's my interval. And the area, if we take a look at the area under the curve, it's going to be negative 6 meters for the first part, then plus 1 for that little small triangle. And then I've kind of split this trapezoid into 1, 10, and 0.5. So I'm going to just keep that all together as 11.5. Okay, and then we end up with negative 4.5, negative 8. So I'm going to go negative 12.5. And then we also have that last trapezoid there, and that's going to be negative 5. So that is my total displacement, or in other words, the total distance traveled. And then we're going to divide that by the total time, which is 20 seconds. So calculating this all, this ends up being negative 7, looks like negative 12 meters over 20 seconds. That works out to be negative 0.6 meters per second. Okay, so that's part A. That's part A. Part B says, find the acceleration for the object for the different time values. So acceleration is slope. Okay, the slope of the velocity function is going to be the acceleration. So basically what we're being asked for is find the slope when t is 3. So I've kind of put a little thing in here. T is 3. We can see that the slope there is going to be negative 1 meter per second. Okay, so then for part B here, it says at t equals 3. So this is going to be a value at 3 is going to be the slope, and that's going to be negative 1 meter per second squared. A at 10, we can see that slope segment at 10 seconds is going to be horizontal. Okay, we have this horizontal slope at that value, at that point. So it's the instantaneous acceleration is going to be 0 meters per second squared. And then at 14, we're looking for the slope of the graph at 14. And we can see at 14, it's at a vertex, at a point there. It's not as smooth and differentiable, so therefore it must be undefined. Okay, so we cannot actually define the acceleration there. Okay, so then for part C, it says find f of t if the acceleration as t approaches 12 from the positive side. So what is acceleration? So in blue here, we're finding the limit or the slope, or the limit of the slope as it approaches 12. Well, it's a constant slope. Okay, it's constantly sloping up, and it looks like it's negative. Well, it's this negative slope is going to be negative 4 over 1. So if we go left to right, it goes down and over. So the slope is negative 4. It's constant, and it's constant as it approaches 12 from the positive side. So the limit of the acceleration then, which is going to be the slope of the velocity graph, so the limit is going to be equal to negative 4. Do this in a different color here. That's going to be, the value of that's going to be equal to negative 4 meters per second squared. That's the acceleration, not just as it approaches 12 from the positive side, but that's going to be true for that whole section. And then lastly, for part D, it says, what's the total distance traveled? Well, we have the net displacement. We calculated that in part A, which was 12 meters. So to find the total distance traveled, so that's D, the distance traveled, we have to add the negative to the positive parts. So instead of using negative 6 meters of displacement, we know that it's traveled 6 meters. In that second part there, we have 11.5, so it's traveled positive 11.5, so we're just going to use 11.5 meters. In the next part there, we have 12.5 negative, but we're going to count that as distance, so it's going to be plus 12.5. And then the last section there is negative 5, but we're going to count that as distance of plus 5. Okay, so then adding this all together, we end up with 24, 30, and 35. It looks like it's 35 meters of displacement. Sorry, not of this, sorry, 35 meters of distance traveled with a displacement of negative 12 meters. There's our displacement. This is the distance.